Okay, hi everyone. This is a new video for DataFlow Functions. I want to show a new use case where the function is going to interact with the Cloudera Data Platform services, and in this case, leverage the new put Iceberg processor. As you know, Iceberg is a table format that has a lot of advantages. And we want in this use case to push data into Iceberg tables in CDW, Cloudera Data Warehouse, as soon as files are landing into S3. So this is a perfect use case for functions. The function is triggered whenever a file is landing in AWS S3. We take the file, we push the file into the Iceberg table formats in CDW, so that the data is available to be queried. This is a perfect use case because you don't want to stream data into Iceberg tables. It's more like micro batch kind of use case. So this kind of trigger-based mechanism is a perfect use case. This use case is also a very good opportunity for me to discuss about some specific, let's say, technicalities of DataFlow functions, how to configure your function when you want to interact with Kerberos-based systems, how to use layers, how to manage SSL, and also how to interact with services in a specific VPC. So this use case is quite advanced in terms of all of the things we need to configure for DataFlow function. But once set up and deployed, you have a perfect mechanism to push data into your Iceberg tables as soon as the data is made available into your S3 bucket. And this is completely serverless, which is the most, let's say, cost-optimized way of running NiFi flows. You don't have to worry about the infrastructure and so on. So that's a really, really great use case of DataFlow functions. So I won't go into the details of what DataFlow functions is because I'm assuming that you are already aware of this. In the description of the video, I will be sharing a few links to, let's say, some blog posts around DataFlow functions in case you want to know more about it. I will go straight into it and focus on the specific configuration details that are really important for this specific use case. All of this will be also documented in the Cloudera documentation. This is work in progress. As soon as I have a link to the Cloudera documentation, I will be updating the description of this video and give you the link so that you have also a text-based description of all of the steps and all of the things required to make this work. Okay, let's get started. So here is my Cloudera, let's say, public clouds interface. So I'm going to go straight into my environment that I'm using for this demo. So I have a CDP environment running on AWS. RAS is enabled. So it means that I'm using the Apache Ranger authorization to control the access to S3. This is a specific feature that is available with Cloudera, so that's in a single place you can manage policies and authorizations for accessing not only the CDP services, but also the underlying storage layer, in this case, S3. So I have my DataHub clusters. In this case, I decided to design my NiFi flow into a DataHub cluster, but you could also do it in the new DataFlow designer of Cloudera DataFlow. Okay, but in this case, I just use a DataHub cluster because I already had one up and running, so I just reused it. So I'm going to go into the NiFi UI, and I will go straight into my process group for my function. This is the flow for my function. This is super straightforward. I already discussed about DataFlow Functions taking data from S3. So I will go quite quickly, but basically the flow is starting with an input port. That's where the DataFlow function framework is going to ingest the payload provided by the cloud provider according to the trigger you configure with your Lambda, with your AWS Lambda function. So in this case, I will be configuring an AWS Lambda with an S3 trigger. So in this input port, whenever the function is triggered, we will be injecting a flow file that is containing the information about the S3 event. This is a JSON payload. This is an array. So the first step is to split it just to remove the array structure. Don't ask me why Amazon is sending an array when you always have a single event, but that's how it is. So we just remove the array structure and then we extract from our S3 event the specific properties that we are looking for. So the bucket name, where the file just landed, the key of the file, and the AWS region where the file landed. Then we just fetch the file by using references. So nothing crazy here, just straightforward access to the bucket. In my case, I'm using access key ID and secret access key. You could use the AWS credential provider service in case you want to use another kind of access to your bucket. But with my function, I'm just using access key ID, secret access key. And then put Iceberg. I shared a video on how to push data into Iceberg. So I will be just going very quickly over this, but basically I'm giving a CSV reader because the data I'm expecting is CSV. For the Hive catalog service, I will be going into this part in a minute. Then you have the name of the database, in this case in CDW, the name of my table, the file format here. So I will be using Parquet, but you can use other file formats if you want. Remember, Parquet is the file format, Iceberg is the table format. Those are very different things. So I'm sending data into Iceberg table using the Iceberg table format, but the data is stored using the Parquet file format. And then I'm using Kerberos to interact with CDW. So I will be using just username and password. Here for the Hive catalog service, this is a really straightforward configuration. I'm just giving the path of where my hive-site and core-site files are located. And I need both files. So the core-site is needed because that's how my processor will know how to push the data into the underlying object store. And the hive-site is containing information on how to interact with HMS, the Hive Metastore service, to make the related operations when pushing data into the table. So that's it. As you can see, I used a lot of parameters. So if I look at the parameters for my use case, I have one for the location of my files. As I said, hive-site and core-site. I have my access key ID for accessing AWS S3 bucket, database name, file format, the user that I'm using to push data into CDW. So I created a service account in my Cloudera public cloud management console. So I created a service account. I associated a password, workload password to that user. So this is the credentials I'm using in the Kerberos controller service. The name of the table, the region where all of this is running, and the secret key for AWS S3 bucket. So those are the parameters required to configure my function. That's all I need. On the NiFi side, I can make some tests, run it, use a generate flow file. do whatever I want to confirm that this is working as expected. So I'm good. I can download the flow definition here. In this case, I don't reference external services. All of the services I need are defined at the level of my process group. You can see it here. The only the two controller services that I need are Hive catalog service, which is in my process group. Well, actually, three controller services. There is one here in my process group. There is one here in my process group, and there is one here, the CSV reader. Actually, in my CSV reader, I'm hard-coded the schema I'm giving for the data. This is a choice. Obviously, I could be interacting with the Cloudera schema registry, or I could be using a parameter to externalize the schema in the configuration of my function. In this case, I just put directly the schema text here in my controller service. So right-click here, download flow definition without external services, and this is downloading my flow as a JSON file. That's all I need to do here. Now I can go here to the DataFlow service and then go into my catalog, and I can import a flow definition here. I can drag and drop my file here, give a name and so on. I already did this, so I will go straight to my flow, and mine is here. So that's it. I uploaded my flow definition here, and I have a CRN here that is corresponding to my flow version. Don't forget to use the CRN that is including the version number, not this one. This one is not including the version number. This one is containing the version number, so don't forget this. That's it. That's all I need here. So that's something I will keep somewhere. Functions, you can download the latest binary to run DataFlow functions. So you can download it, and then you can go straight to AWS and go into the Lambda service. So that's it. I will go very quickly on the basic configuration of the Lambda because I already covered this quite a bit, and this is very well documented in the Cloudera documentation. So let me show you the function I have here. So that's my Lambda. So I created my Lambda. In terms of code, I did upload from Amazon S3 location. I uploaded the file that I got from the DataFlow service that I just showed you before. I'm selecting Java 8 in this case, and I'm updating the handler so that I'm referencing the correct part of the framework. I'm adding a layer to my function. I will come back to this, but I'm using layers to make available some files into my function. So we will be using this for example, providing the hive-site and core-site files. I will get back to this in a minute. In the configuration, general configuration, I'm increasing the timeout. I did a lot of testing, so the 10 minutes timeout is definitely not required. You can get this down to 1 or 2 minutes if you want. Excuse me. I increased the memory to 2 gigs and the ephemeral storage because the main reason is that we are going to download the Iceberg NAR file containing the Iceberg processor. And unfortunately, this NAR file is very large. So you need to increase the ephemeral storage. So yeah, here I really took very large numbers. You can definitely decrease those numbers to be more fine-tuned. Actually, if I look at metrics for recent, sorry, recent invocations. Yeah, so here, for example, this is running for 36 seconds to push a file, and the memory used was only half a gig, so I can clearly decrease the amount of memory required here. So anyway, you can definitely do fine-tuning here. Permissions, I will get back to this, but when you create your Lambda, a role is going to be created. And from here, you can access the corresponding place in AWS where you can edit the permissions for your Lambda. There are quite a few things we are going to change. I'm providing permissions, for example, to access AWS Secrets Manager. And we also have some additional permissions. So I will get back to this in a minute. Environment variables. So here is some interesting information. So here, in this case, you have the three usual required properties here, where I'm providing access key and private key of the user that I'm using by the function to access the flow definition in the data flow catalog. So this is a user I created in the control plane and for which I generated access keys. And I also gave this user permission, read-only access permissions to the data flow catalog. So this is the user that the function will be using to access the flow definition to be executed as a function. And I'm giving the CRN of the flow definition. So those three variables are required. Then we have two things here that are important, and I will get back to this in a minute. And then we have some variables corresponding to the parameters of my flow. So just make sure that the key is the same as the name of the parameter in your parameter context, and that's fine. And as you can notice, some parameters, the sensitive ones, are not available here. This is because for the sensitive parameters, I stored those into AWS Secret Manager. I will get back to all of this. There are many things to cover from, let's say, configuration point of view. The first thing I want to cover is networking. And bear with me, I'm not a network expert here. This is actually the thing I hate the most, probably. So I just want to explain with my very little knowledge what is required. Basically, we want our function to interact with services in our CDP environment. Our CDP environment has a VPC. So we want our function to run in a VPC. So when you configure this, you will be asked to give the VPC in which you want to run the function. So you can select the VPC of your CDP environment, and then you can choose subnets. So in theory, here you would select 2 or 3 subnets. In my case, I just chose 1 because I'm lazy, but it doesn't change anything. You could choose 2 or 3 here. You can also provide a security group here. I just use one that is already existing. But here, I mean, honestly, this is a straightforward one. Like inbound rules, we don't need anything. And outbound rules, we just need access to everything. Because the function needs to access everything, but nothing is going into the function. So I just reused an existing security group because I was lazy to create one dedicated to my function. So all of those specific rules are just basic ones. You don't really need this. And outbound rules just allow the function to access anything. So that's it. However, something that is really important to keep in mind is that your function, your Lambda, AWS Lambda function needs access to the internet. This is important because when the function is starting for the first time, not the first time, but when your function is triggered, the function is going to access the data flow catalog to download the flow definition to be executed as a function. Okay. And this happens over the internet because the data flow catalog is something that is hosted by Cloudera. This is Cloudera owned service. So all of this is happening over the internet. So you need your function to have access to the internet. And to do that, this is one thing. And the other thing is when you select your VPC and then the subnets, you can only select private subnets because AWS Lambda is not able to create lambdas with public IPs in a public subnet. So you have to select private subnets, okay? Well, if you are following best practices, you would have private subnets already configured for you with your CDP environment. In my case, my CDP environment was not containing private subnets because I was only using one with public subnets. But as I said, it's really, I mean, in theory, you should have a CDP environment with private subnets anyway. So you would just choose your 3 private subnets. In case you have a CDP environment with only public subnets, it's easy. You just create a private subnet. You make sure you have a root table and a NAT. Okay, so the NAT is what will be giving access to the internet. The NAT is linked to my public subnets in the same availability zone. Okay, so I won't go into details here. I don't want to go step by step on all of this. We have documentation in Cloudera describing all of the steps required to do that. Again, in most cases, you shouldn't need this because you already have private subnets. If you don't, that's really what you need to do. Private subnet, root table, NAT. Okay, and this is important to have all of this because we will come back to this a bit later. This is important. Here, if we look at our root table, we will see that we have 2 roots. One that is the default. So for all internal IPs for my VPC, the target is local. So basically, if the function is trying to access services within the CDP environment over internal IPs, we will keep all of the traffic internal. For everything else, we will go to our NAT and go through the internet. Okay. So that's really what we have here. As I said, we will come back to this. So actually, one thing to note is that when you are associating all of this, sorry, when you are associating all of this to your Lambda, you will be asked to add some permissions to your Lambda so that your Lambda can create some network interface and tags. So you need to add those permissions. Create network interface, describe network interfaces, create tags, delete network interface. So you will need to create this inline policy and attach it to your role so that Lambda can do this, to basically create all of the stuff it requires in your network. So that's when your Lambda is triggered, it's starting in the right subnet and with the right interfaces and so on. So this is a policy you will need to add. But AWS will tell you all of this when you attach your Lambda to the VPC. So that's the first step. That's the first thing. Network, so that the Lambda can run in the VPC and access the internet. That's the first step. Now, second step, we want our Lambda to interact with the CDP services over, I mean, not over, but with Kerberos access, Kerberos authentication. So the first thing in this case is to configure the KRB5 file. So we will be giving the file through the layer. I will get back to this in a minute. But here you need to define an environment variable saying that the KRB5 file will be made available in a specific location. You need to specify this environment variable. Okay, so to get the KRB5 file, you can just access SSH one of your nodes in your CDP environment. It can be a node of a DataLake if you want, or one of the NiFi node of your DataHub cluster. You just get the file, and that's the file you want to use. However, you will need to make some modifications in that file. That's the first step, let's say, where we need to make some manual modifications. So let me actually switch to this. So this is my KRB5 file. What I had to add is this part here. So you need to give the IP addresses of where things are running. So I will tell you where to find those IP addresses, but that's basically what I had to add in my KRB5.conf file before adding it in the layer. Okay, so that's something important because by default this is not included. So those lines are what I added. Okay, so let me get back to here. So if you go to your environment, you go in your data lake. Sorry, actually, you can go directly to FreeIPA, and here you have your two FreeIPA servers. So I just took those two IPs here. I'm using the private one because I want, I mean, again, the Lambda is running in the VPC, so I want internal communication. I don't want this to go over the internet. So I just take those two IPs here, and that's what I'm using in my krb5.conf file. Okay. So that's the thing. So now how do I give this krb5.conf file to my Lambda? For this, you use a layer. So a layer is basically a zip file. So, so when you go to Lambda here, you can go to layers, you can create a layer, you can give a name, upload a zip file, and that's it. Optionally, you can specify architecture and runtimes, but just don't do it. It's not required. I mean, you can do it if you want. So this zip file will be provided to your Lambda when your Lambda is triggered and created. And all of the files of your zip file will be made available in /opt of your Lambda. So that's the reason, if I go back to my function, that's the reason why in my configuration, I said that my krb5 file will be in /opt/krb5conf. Okay, because in my zip file, I just gave my files at the root of my zip file. Okay, I didn't create any kind of folders and so on. You can do it if you want. But basically, if the files are at the root of the zip file, all of the files will be in /opt/opt. So that's one thing. Okay, that's for Kerberos. That was the first step. Okay. Now the next thing is to look at core-site and hive-site. Okay, so let's start with hive-site. So both files can be retrieved from the DataHub cluster if you want, like the NiFi DataHub cluster, or you can connect to the master node of your DataLake and retrieve the files from there. It's really up to you. In my case, I took the files that are made available in my NiFi DataHub cluster because that's basically what I used. I think this is good practice to have this DataHub cluster, run things, test things, and just take the files from there. Obviously, if you are using the DataFlow Designer, you will need to do things slightly differently, and in this case, go into the data lake. Okay, so once you retrieve the files, you can just put the files into your layer. However, here again, you will need to do some manual changes to your files. So let's start with the hive-site file, and let me switch to this. So here is my hive-site file. I just took it as is. So as you can see, we have the address of the HMS, which is on the data lake on the master node. I just have one because I don't have HA in this case, but if you have an HA enabled environment, you would see multiple thrift addresses here for multiple HMS. S3 location of your HMS warehouse, things like that. A lot of configuration. Something that I'm looking for is this Hive Metastore Kerberos principle. By default, this is not this. By default, this will be something like this. And if you use something like this, when your code is going to be executed in the Lambda, host will be replaced by the actual host of where the Lambda is running. But if you do this, well, obviously, we didn't create the corresponding principle in your KDC. So you don't want to do that. You don't want to keep host here because basically your Lambda is going to run on a dynamically generated host that is not known in your KDC. So here, I'm just going to replace with the FQDN of my master node. And that's it. That's the only change you need to do in the hive-site file. And then like it's good to see that here for thrift, you are going to access the master node. And here in the file, you can see that you are using the public address. Okay, so this is something, I will get back to this later, but this is something important as well. In the core sites, we have also many things here. So we have a lot of information about the underlying object store in S3, RAS information, Ranger authorization, server information. So we have a lot of things here. And in particular, the thing that I want to mention here is this one here. So here we have the address of the host where the Ranger authorization server is running. Here I changed it because by default, it will give you a comma separated list of hosts in my NiFi DataHub cluster. But the DataHub cluster is not supposed to be always around. I mean, assuming that pushing data into CDW is my only use case, I'm not going to keep my DataHub up and running, okay? my DataHub cluster is going to be stopped. So I don't want my DataHub cluster to be required to run my Lambda. So here in this case, I went into here and replaced here the list by my master node in my DataLake. You would be able to give a list of hosts if you use HA DataLake. In my case, I'm not using HA, so I have only one. In a real life use case, you will have multiple nodes here to ensure that you have HA. As you can see here, we are using HTTPS, which means that our function will need a trustor so that we can trust this endpoint, which brings us to the next interesting thing to note here, is that we need to provide a trustor to our Lambda. So if you, let me switch back to my Lambda. So if you go to your DataHub cluster or really any node of your CDP environment, you can find this file that is generated by Cloudera Manager. So here, CM auto global trustor GKS, and you can retrieve its password as well. This is usually available in a file next to this file. And to make this trustor available to your Lambda, you will need to use this environment variable, Java tool options, and provide this configuration. If you want to create your own trustor and things like that, you can also go to your here to your to your CDP environment, and you can download here get FreeIPA certificate. If you want, you can do that as well. This will be the CA. Actually, I'm saying something wrong. I just want to make sure I'm not saying anything stupid here. No, that's it. So that's how you can retrieve the CA file that is used to sign things internally. So that's how you can create your own key store if you don't want to retrieve one from one of the nodes. So that's how you provide the trustor to your Lambda. So using those options, and obviously you need to also add this file into your layer. In the end, that's all I have in my layer. I have my KRB5 conf file, I have my hive-site file, I have my core-site file, and I have my trustor file. In my layer, I have 4 files, nothing else. Okay, that's all I need. So that's it in terms of things you need to change in the files. Okay. Now, if I go back to the files, there is something a bit well, tricky. Is that, as you can see here, so I'm going to access RAS over HTTPS. That's why I gave my trustor. But here you can see that I'm using public FQDN. So when my Lambda is running and it's trying to resolve this FQDN into an IP, the IP is going to be the public one. Okay, so because of this, the traffic is not going to be internal. Okay, so you can see here it's master 0. So let me go back to here, and if I go to my data lake and then nodes, my master 0 here. So this is going to be resolved with this public IP. And if you remember what I configured for the network of my Lambda, this was this was using a route table, and only the traffic on 10.10.00/16 was staying in my VPC. In this case, it's going to the internet. So I will need to update my security group to allow some access from the outside. So obviously, I don't want to open everything to the world. That would be really bad. So this is where there is something important here. So if I go back to my VPC configuration and I open here, so when you configure your Lambda to run within your private subnet with the route table and the NAT and so on, here it will create an elastic network interface with an elastic IP address. So that's something important, because here you can see that it will get a public IP, and that's the IP that will be used for your Lambda to access the services. Okay, so here, if I go to my instance here, my master node, and I look into security, I have a security group. And here, in my case, what I'm doing is opening my security group with an additional inbound rule, allowing access from this IP. So the IP, the elastic IP that has been associated to my NAT gateway. So that's the thing you need to keep in mind. You could say, okay, but I don't want to do that. So instead of doing this, I want to manually change here the public FQDN by the private one, or using IPs and so on. But if you do that, this would cause issues with the trustor, because the SAN exposed by the certificate of this endpoint wouldn't match what you are trying to access, and so on and so on. So there are other ways to look into this with a private DNS resolver and things like that. But in my case, I chose to do it this way. So not saying this is the only way, but that's one way of doing it. So yeah, that's really what to keep in mind. So the core site is containing this information about access to the RAS servers, and the hive site is also containing kind of the same here to access the Thrift metastore. So that's also something we need here. And that's it. So that's really all of the things I need from a configuration point of view. I just want to now go back to my Lambda, and I can test it. So here I'm going to test from here without spending a lot of time. So I'm creating a specific event. I'm using the S3 template they provide, and here I just changed two things, because if you remember, we just need the bucket name and the object key. So in my buckets, I pushed already a CSV file that I want to ingest. All of the other values are part of the templates provided by AWS. You just can ignore it. I just changed the name of the bucket and the key for the file. So that's it. And I can click, sorry, I forgot to get back to the other screen. Okay, so I was saying that now you can go to the test section, and here you can select the S3 trigger template, and you can just change the bucket name here and the object key here. And this is basically simulating the fact that a file with this name just landed into my bucket here. Okay, so here I can click tests, and this is going to run the function. So while this is running, I just going to summarize all of the things you really need to think about when deploying this function. First thing is the network. You need to attach your Lambda to the VPC of your CDP environment. Well, I mean, technically speaking, this is not absolutely required. You will have all of the traffic going over the internet if you want, assuming that you are opening the right security groups and so on. But clearly not something we would recommend. So you want to attach your Lambda to the VPC of your CDP environment and make sure that you have a private subnet with the root table and the NAT gateway so that your Lambda can access the internet. And you want to attach multiple subnets for high availability. That's the first thing. Second thing is to retrieve the kerberos.conf file from one of the nodes of your DataHub cluster or DataLake. And you want to add the IPs to the FreeIPA servers of your CDP environment and use the private IPs so that this traffic is staying internal. That's the second thing, and you put this file into a layer. Third thing is the core-site file, and in the core-site file, you want to change the RAS endpoint, the address of the Ranger authorization server, so that it's not pointing to the ones you have in your DataHub cluster, because you don't want to assume that your DataHub clusters will be always running. And because this communication is done over HTTPS, you will need to provide a trustor. So you need to add the trustor CM auto global trustor.gks to your layer and provide the path and password as a specific environment variable Java tool options. Then you need the hive-site, and in the hive-site, you need to replace _host by the actual FQDN of the master node of your data lake. Because otherwise, when your Lambda is running, host will be replaced by where the Lambda is running, and this host will not be known in your KDC, FreeIPA in this case. And finally, since some of the things we interact with are given with public FQDNs, these FQDNs will be resolved by public IPs. So some of the traffic will go out of your private subnet. I mean, it won't use the root table on the 10.10.00.16 CIDR. So in this case, you need to update your security group with the elastic IP address that has been provisioned with your NAT gateway, because that's how the access will be done to your CDP services. So those are the 5 things you need to do to configure your Lambda in this use case. Okay, so here my function is running, and this is now success. You may ask why this is taking so long. This is because, remember, this is a cold start. The function is triggered for the very first time. And when it's triggered for the very first time, we are downloading the nars that are required for the function. So if I look into the logs here, let me go back up and explain everything that happened. Okay, so here it's starting Java 8. I'm providing the options with the trustor. Here we download the flow definition from the catalog. So that's one thing. That's where we use our user to access the DataFlow catalog and download the flow definition. Then we start NiFi here. This is taking 6 seconds. Then we are looking into the flow definition itself, and we see that we have some extensions to download. Okay, so that's where we say, okay, we have some nars to download. Sorry, that's not this one. Yeah, here, beginning download of extensions. So here we see that we are downloading a bunch of extensions, and in particular the AWS components and the Iceberg components. Okay. Also here we see that we correctly configured our Kerberos configuration to the file we provided through a layer. Okay, so here we download the files over the internet. I already mentioned this in the past, but this can be taking quite some time. And here, actually, we can see that we start here, here, and until here. We take almost 3 minutes, like two minutes and a half, 2 minutes and a half to download all of the extensions and making all of this available. Again, this is because the Iceberg extensions are huge. So this is something where if you want, you can pre-download by yourself the extensions and make those extensions available into S3 bucket, and this would make things faster. We are also looking into much better solutions for this, because as you can see, this is taking quite some time just to download the extensions. But again, all of this is done only when this is a cold start. If you have a file landing into S3 every minute, for example, you won't have the cold start again, and this will be much faster. Okay, so here we are loading everything, then we are loading the flow. The flow is loaded, and here we can see that it took about 1.5 seconds to load everything. We also retrieve the parameter values from AWS Secrets Manager and so on. Here we inject the flow file with the information from AWS, and this is going into the processor. So speed.json, fetch it, S3. So we retrieve the file from the bucket, and then we access the Hive meta store. Here there is an error in Ranger RAS because we try to retrieve EC2 metadata, but since we are using Lambda, this is not something we can do. But you can ignore this error, and this will be fixed in the next release. You won't see it anymore. So this is just an error, but the code keeps going. You can just ignore this stack trace. It won't be there anymore in the next release. And then we are pushing the data, converting it into Parquet and so on, and committing things. And we have the full duration of the Lambda, and like the Lambda is successful. Okay, if I trigger it again, you will see that it's much faster, because in this case, this is not a cold start anymore. Actually, if I resume here, it should be using the same log stream, and here you can see that this is much faster, because in this case, we just go straight to the point. We don't have the processors to load anymore. We just get the event, we retrieve the data from S3, and we load into things into a CDW. So in this case, the event just took 6 seconds to be processed. Okay. I can run it one more time. And here, this is going to take a few seconds, but again, we have a new event, and in this case, this has been processed in 4 or 5 seconds. So again, when this is a cold start, this is taking a long time, specifically because we have to download the extensions, and the Iceberg extension is very large. There are workarounds, as I mentioned, but this is the reason why the first execution of the function is taking quite some time. So that's it. I can quickly go into my CDW instance and show you that I have some data there. So here, so here I can run my queries using Impala. So if I do select count star from this, so here I can see that I have 5,964 events records in my table, same value here. And if I run again my Lambda here to push data, so here this is executed. If I run my query again, the data is now available, and I have 6,461 records in my table because I pushed about 500 events from my CSV file that just landed into Iceberg. So that's it. That's how you configure your Lambda. If you want to push this, then you can go to publish version here. You can publish your version. And then that's quite straightforward. Once you're on your version here, you can go into triggers and you can add a trigger. You can select S3. You can select the bucket you want. So, sorry, Iceberg here. For all objects, create events. So whenever a file lands into my bucket, and that's it. I acknowledge, add, and that's done. My Lambda would have the S3 trigger, and now my function will be triggered every time a file is landing into my bucket. And that's it. So I hope it was useful. This was really a 301 explanation of DataFlow function in a very complicated use case where we have Kerberos authentication. We need to take care of networking, let's say complexity, where we need Trustor for TLS communication, where we need to take care of some manual replacements in some files and so on. So hopefully this was interesting and useful. And this is a great use case for using DataFlow functions. I will be doing more videos in the future on DataFlow functions. If you have use cases in mind and specific questions on DataFlow functions, feel free to leave a comment and I will answer as soon as possible. In any case, thanks for watching and see you soon in the next video.